Oh, you've got it set up for with the well, it's not a laptop, but your computer.
Yeah, no, that's a it's a full system. Yeah. Well, the computer, actually, the telescope, as we'll see, the telescope is all computer controlled, so I can't touch it until it's like once it's already up to and ready to go. Like now, it's up and running, but I can't manually move it. It's set now.
It moves itself.
Yeah, it's all oriented right now. The North Pole's over there, so it's aligned perfectly with the pole. And I mean perfectly. Yeah. It's supposed to be aligned perfectly to be able to be accurate. So if I look for something way over in the western horizon or over in the eastern horizon, it's right in there because I took the time ahead of time to make sure this gets all lined up.
It's great, man.
Yeah, and it should be fun.
Good for you.
Yeah, this is the home of SkyTour LiveStream, where we, my YouTube channel, and on clear nights, which is not tonight, unfortunately, but on clear nights we actually broadcast to the world, and we actually take people on a tour of the night sky. Tonight's a little different because we got the, everybody here and so forth. But the nice thing is that when we do the sky tours, people can actually see really dim objects in the sky, because my camera that I use, which is that one there, can go to a very, very high sensitivity in no time. It goes, you know how cameras go to like 1600, 3200 ASA, right? They call it, or ISO. Well, that camera goes to 409,000 ISO, and that's just a setting. It just goes and it's there. So that's perfect, and that gives me the ability to broadcast anything. It turns night into day. When this is dark here, it'll look like daytime when I just change the settings a little bit. It's really
fast processor on it.
Very fast. It's the Exmor chip. That's
I'm a photographer, so.
Yeah, okay. Yeah. So that's the A7S II. Yeah.
It's a Sony, right?
Yeah. Modified for astronomical use, though. So.
What lens is that?
Oh, that's a Nikon, actually. That's
what I shoot. That's what I thought when I looked at it.
Yeah, it's a Nikon.
That same lens in the car.
It's a Nikon lens, yeah, and I just have a little Velo adapter to go from the Sony E mount to this.
Yeah, that's what I thought it was.
Yeah, it's very simple to use,
1.2?
No, not at all. It's not. This is a. It goes as low as well tonight. It's like f3.5, but it'll go to f2. I have a 2.8 300 in the house.
Yeah, the big ones.
Big piece of glass, and that's kind of a waste, in a sense,
Well, for this kind of stuff, definitely.
Yeah. Well, what I do is, I don't know if you saw in the telescope, I actually 3D printed mounts for the camera and for other stuff, so I can actually put the camera right up in the back. There's a mount for like the big 300 I can put on there. It's on a rail, so it just put it anywhere. That's really cool. So right now, this scene here that we're shooting, I'm at a 15th, but I can actually go, say, to if I go to a 60th right now, and if I could just pop it up, I can actually bring it right up to 320,000 ASA, just like that. And now,
that's great for video.
Oh yeah, I can do this. You can do 4K video with this.
Yeah.
But I'm effectively doing that because I'm actually going to, this is 409,000. I'm actually going to the YouTube with this. This is live.
Your actual image size though, is it?
Well,
how many megapixels?
It's 25.2.
25.2.
But this guy, this camera here, when it goes to YouTube, it ends up being a 1080p stream.
That's like I have an 810 that's 34.
Okay.
And that's true HD.
Yeah.
1080p.
Yeah. Okay. So this is great. This gives me everything that I need. It doesn't. I can go to 80,000 here and just leave it.
That's awesome.
Yeah.
It's good stuff. It's a nice little setup you got here.
Yeah, this is all I need.
Yeah, and when I was driving up, I was like, I wonder what the light pollution is like up there.
Well, up here it's moderate, but once this is all automated, because I can run the whole thing right now from in the house. I don't even have to come out except to move the dome. But when I when I get it fully automated, and I get the shutter movement and the dome actuator in there, which is only it's another few $100. Then I'm gonna take this down. It's temporarily mounted on shipping pallets.
Yeah, I noticed that.
And it's going to Arizona because I'm gonna bring it and it's gonna go into a truly dark sky. you know, because I've never had a truly dark sky, and I'm sick of that. You know, I'm done. I'm done with winter. I want to get to dark sky and stay there. So we'll see what happens. You know?
Yeah, there's great places in Vermont that you get zero light pollution.
There's places in Vermont. There's places, but there's winter in Vermont too.
There's definitely winter in Vermont.
There's winter in Vermont.
No doubt. No doubt about that.
Yeah. And we want to avoid that, like the plague, you know, if we can.
Yeah.
You know.
I hear you.
Yeah.
I'm with you.
Yeah. Well, my hands hurt. You know, I can't stand it. You know, I can't deal with that anymore.
If you look on it,
So.
That's awesome. How'd you fall into this?
I've been an astronomer since I was age 9, and then I started investigating UFOs around the same time. Are you in MUFON?
I just joined.
You did? Okay. I've been in MUFON since 1971.
Wow.
Yeah. So you know.
Wow, you look.
I'm 56. Yeah. So you know. But you know. And being that I've been there for a while, I ended up becoming their chief photo and video analyst. So, and that's because Mark. What?
This is the name?
Yeah. Keep guessing or I won't answer. No, I'm just kidding. I'm Mark.
We're talking about.
That's fine.
Take a look at that.
What do you got?
When you're done.
Okay.
You got something.
Yeah, I'm just gonna.
It's a nice tripod.
Oh, that's a little Bogan that I picked up. I actually used to support.
Did you modify it?
No, not at all. Actually, I didn't. Well, no,
This mount here?
Yeah, no. This head might be. I think it's the same head that came with the original Bogan, and I think I might have had to buy that head separately. Actually, as I think about it.
Yeah, that's what
and you're probably thinking that's why you're saying that.
Yeah.
Because Bogan usually comes with the legs.
Yeah.
And then you buy the head, you know.
Yeah.
And I don't have a fluid head, you know, thing for this, so it's doing okay. You shine it at my neighbors, they're gonna like shoot you. Oh, okay.
What is that down there? Oh, that's the road. This is the 8.
Awesome, man.
Yeah.
Great setup. Congratulations on your.
Thanks. Well, I'm glad you joined it. I'm glad you joined MUFON.
Yeah, I've been interested for a long time, and
Yeah.
I just. I'm a photographer.
Yeah.
I've done a lot of stuff for like Getty and Getty Images.
Yeah.
For like editorials or whatever, and I ended up just kind of reading about MUFON being pretty much in my backyard, so I went and checked it out.
Awesome.
I'm gonna go check it out again.
Yeah.
Joined. It's interesting.
Yeah.
Definitely an interesting.
Yeah. You know, we end up going. I do a lot of conferences all over the country. I just got back from Roswell, New Mexico. Kind of where it all started, and I had to do a talk out there, and that was really cool. You know.
Did you do contact? Do you do contact?
I didn't do contact in the desert. No. And I didn't do the MUFON symposium this year. I did last year, but not this year. You know, I spoke last year, and then UFO Congress I spoke, and then let's see, I'm speaking at Devil's Tower in Wyoming in September.
That's cool.
Oh, nice. So you do that conference?
Yeah.
Yeah, I was thinking about
They want me to come out and talk, so I'm going to have to do a talk, and then October I'll be in Leominster, Mass, doing a talk there, and then I haven't thought too far ahead after that. You know?
Yeah, that's
See,
cool. Man.
this is recording now. See, this is recording it in 4K. So now when you do the recording, okay, you get the full benefit of what the ASA can do, obviously, as you know. So I can go like, you know, wait till it's too high, you know. And this is, you know, at 80,000, reasonable. And look, it's dark, yet it's full color.
Yeah, but it's you know, it's not dragging too much either, considering how high that ISO is.
Right. Considering also that I'm actually, okay, if we go to there, you see that I'm actually at a 1/6 of a second, okay, a 6-second exposure. If I go to, you know, see what I'm doing, if I go to 30th or 40th or
I love that, how it's just lighting him.
Isn't that cool?
Yeah.
Well, and that's because he's the hot spot, obviously, yeah. But yeah, and 15th is typically as low as I like to go, because otherwise it really looks really bad when
I typically don't go too, unless I'm on a tripod.
Yeah.
And I'm literally shooting something on a long exposure.
Yeah.
I'll go down.
Yeah. And this is just for the stream. I'll go to, like I am now, like an 1/8 of a second, and just let it go. You know, 1/8 of a second per exposure. That's fine.
That's cool.
Yeah. So then, you know, we got everybody's over. It's like you can kind of basically check everybody out and stuff like that, and they don't even know you're looking at them. You know, like here we could zoom in on Armando over there. See, this Armando doesn't have any idea, and it's like, see, here we go. Now this is Armando. Okay, here we go, folks. We're gonna zoom in on Armando Landry, and here he goes. Okay. Whoops, I just defocused him. Let me zoom in, and now we'll focus on Armando. If we can just get somebody to get out of the way there, of course, that's okay. And
yeah, it's great, man.
But you get the idea.
Yeah, these lenses are pretty great.
Yeah, the only problem with the Nikon is that it doesn't do the autofocus with the Sony. Because the Velo says it will do it, but it doesn't.
But it doesn't. Yeah. What you have to do is you have to get there's a motor mount that you can get.
Yeah.
That will actually do it for you.
Well,
I think that's like $25.
I think it was supposed to, you know, pass the signal from the Nikon through, but it doesn't. I'm sorry, from the Sony through.
Sony,
yeah, but it doesn't.
There you are. Wait.
Yeah. Oh yeah, he's there.
I only use Nikon, but
yeah.
I have used my lenses on other cameras.
Believe me, it took me a lot to buy a Sony, but then by a lot, I mean I had to see the result. And when I saw the ASA range, the ISO range in this, and because I'm working with a guy named Douglas Trumbull. I don't know if you know who he is. He's Academy Award winner, legendary special effects guy. He did all the effects for Blade Runner, Close Encounters of the Third Kind.
Oh, yeah.
Okay, and Doug and I have been friends for 6 years now.
Well, you're in that business, aren't you?
Most
yeah.
importantly is that he was the director for Brainstorm.
Brainstorm, that's right.
Last film, and that is with Christopher Walken, and that is a masterpiece.
Right. You were in the
I haven't seen it.
You came up to that event. You were at the event that I put together at the studio, right? You were at the event. You came up, right? Yeah. Okay, good.
That was awesome. Yeah. You put that together.
Yeah, I did all that. Yeah, I put that together because Doug doesn't put that stuff together.
I've seen some of the stuff that you've done.
Yeah.
Like just looking on your bio.
There's Jupiter. Yeah.
Looking at your bio, there was a couple mentions of things that I had seen before.
Okay.
That you had done the effects for, or I think you may have done some digital stuff for it. But
I have. I've done well for I do the seasons of NASA Unexplained Files. I do What on Earth, and those are Discovery Channel, Learning Channel. I forget the other channel, but then those shows sometimes they'll ask me to do the visual effects stuff. Yeah. Visual effects is props and models, things like that. Special effects is computer stuff.
Right.
Okay, I've done both, but I do primarily visual effects because it's more fun. For instance, I'm holding in my hand. This actually, you can't really see it too well. Warren, you have a regular flashlight?
Mark, what's that?
That's Vega. Yeah. I'll show you. That's actually that's Pluto's surface from New Horizons.
Did you print that?
I did. I 3D printed that just a couple hours ago, and then I painted it up, to make it accurate.
Yeah, it looks great, man.
Yeah, and it's all solid plastic, and it's beautiful.
Yeah, that's great work.
And I kept it, I mean, I print out sections of the moon. I print out.
You can make it look so great though, like with the close up. Like look at the way the light.
Yeah, the raking light is beautiful. Like just like what Pluto would be when it's orbiting or like when it's rotating on its axis. You just get that little. Yeah. See, and I like that stuff. I'm
a texture guy. Pictures.
Exactly.
That's what I focus on. Yeah. Textures.
Well, so I printed this out because I thought the Pluto textures were just phenomenal. The texture of that little dwarf planet is just outstanding. Yeah.
I get it.
Yeah. Outstanding.
Hey Mark, here, have this.
What?
Is that Venus?
No. That's Arcturus. That's Arcturus. That's Vega. Okay, that's Jupiter there.
Where's Jupiter?
Right there.
Oh, that's Jupiter.
Yeah. Yeah, we'll check it out in a little while. I'll put the camera on the telescope. We'll just go take a peek.
Sweet. This is starting to clear up a little bit.
Yeah, well, that's as it gets.
Hey, can they fit 13,000 Earths inside Jupiter? I thought someone said 13,000.
Really? That's about right. Over 1 million inside the sun, but who's counting?
How much of it has some solid core, doesn't it?
Well, it's more like it's called metallic hydrogen. I did a whole I did a whole discussion of that, you know, with folks, and you know, at a conference.
Like liquid iron and argon.
Well, actually, mostly hydrogen, actually, with a little helium.
Well, they say the moon is harder on the outside than it is in the inside. Could be hollow spots. Do you believe that too?
The moon, our moon?
Yeah.
Well, see, the surface of the moon is, of course, you know, the lunar regolith, and that's just, you know, the soil. But I don't believe that it's actually, you know.
You ever hear that? The outside of the moon is harder than the inside because the rocks they found. They said they should have been found like you know, like way down deep.
Yeah, I mean, I remember that. Yeah, but that was because of the material dredged up by some of the impacts on the moon.
Okay, so it hit down there, broke up.
Yeah, right. Yeah.
Splashed.
Yeah. Yep. Exactly right.
Trash somewhere?
Oh, you know what there is actually. If you want to use your phone to just walk kind of toward the house,
Yeah.
just
Underneath?
around the left, there's a little garbage bin that you can find. Sure, it's right there.
Anybody else need anything thrown out?
All right, that's very kind of you.
Do you think there's structures on the moon?
Not necessarily.
Really?
You know.
A lot of times, some of those pictures I see, you know, they make up these things here. I don't know.
Yeah, and I wasn't too excited about that show.
Because they say the Hubble telescope can't correlate to the moon because it's too bright. Is that, you think that's true or that's
No, that's not. That's somebody just trying to make an excuse. The reason that the Hubble can't actually see, for instance, the Apollo landing sites, is because for the Hubble to see those, it would require the Hubble to actually be able to resolve something that's less than a pixel in size.
All right.
The moon landing
Analyze
sites,
it then, okay.
well, the moon landing sites are less than a pixel in size.
All right.
And remember, an image is made up of many pixels.
Okay.
So 1 pixel is just a brightness value,
All right.
a shaded gray.
Now, don't you think after all those years, we sent a satellite to the moon and we already mapped the moon very close,
Yeah,
and we have
right.
the pictures, but they won't show us? Or is that
No, I don't think so. I think that's just all, you know.
a lot of conspiracy stuff out
I do. I think that's all conspiracy stuff that doesn't have any bearing on reality there. Yeah. Yeah. So, but that's my.
there? I love to talk to Buzz Aldrin or somebody, you know.
Well,
Dental field, give them some sodium pentothal, serum, you know. Like,
I don't think you'd learn anything, unfortunately. I mean, you know, I went to it was lunch, I think. It was lunch, yeah. I went to lunch with Alan Bean from Apollo 12, and he was actually speaking at a venue that I was attending his talk.
yeah.
But I went up to him later and then told him who I was, what I do, and everything. And he said, you know, why don't you come to lunch? And so I went to lunch with him and the rest of the people that actually hired him to come there and talk.
Wow.
And they were kind of mad at me because he wanted me to sit next to him. We were talking. And unfortunately, you know, Buzz, great guy, great painter, and I was also doing artwork, and I was showing him some of my paintings, and he was talking to me about my paintings. I was talking about his. And then he was basically telling me how, you know, he was just doing his job as an Air Force guy.
Yeah.
You know, that's all it was. They never expected to get the enduring.
And if you think what they did, that's like the biggest feat of human history.
Yeah.
And people forget about that right now. I mean, you're like on a tin can, basically.
They never.
Oh, yeah, that's a freaking moon.
They never actually expected to get that popularity, that enduring mythos that surrounded them after this.
Yeah.
Never, ever did they expect
I heard, like,
it.
before people from Australia, one lady from Australia said, "Oh, it's like Coke can and the TV, you know, a lot of crap, you know, like is it true?" A lot of people still don't think we landed on the moon.
I know. I did on NASA's Unexplained Files. I did for season 1 actually. That's how far back it was.
Yeah.
I actually did I made a moon. I have it in my workshop actually, in my special effects shop inside. I've actually got the moon. It's a big flat moon surface.
Yeah.
And it was it was used to dispel the lunar landing myth, because I pointed out to folks that,
Or the non-lunar landing myth, you're saying.
well, to dispel it, to make people to like, yeah, that's right.
Right, yeah.
Yeah, to show people that not only did we land there, here's why the assertions of the moon hoaxers are false. And I proceeded to show how the shadows look like they're going the wrong way.
Right, different angles. Because
Right. But then if you raise that camera up and look down on top of the moon from the very same vantage point, down here it looks like they're going the wrong way.
Yeah.
Don't change the shot, don't even turn the camera up, but take it up and look down. They're all parallel. They're doing the So why the wrong way? Because the moon has undulating surface, and that undulating surface changes the apparent path.
That moon bag for $995, sold it for $1.8 million. They sold yesterday. And
I didn't hear about that.
did you hear about the lady about the moon from NASA, one of the astronauts' moon bag? cover the moon.
Really?
It's full of moon dust. She bought it for $9.95 at a place at $995. She sold it yesterday for $1.8 million.
Wow.
Well, NASA wanted it back, and the government and the court says no, you can't have it back. Because somehow they said it got released without us really knowing about it, but it was released.
Oh, that's so funny.
She was legally the owner of it.
Well, that's good for her.
I know. She made like $1.995 million.
Good for her. That's good for her. Hey folks, if you're just joining us, I just want to let you know this is the SkyTour LiveStream special event. We are streaming a Skywatch and Star Party here at John Zach Memorial Observatory. You can see we have quite a crowd on the around the observatory here, and we're going to be leaving the camera on the tripod for a while. It's not really quite dark yet, and the sky is kind of bad tonight for astronomy per se, but so you're not really missing much. But I did want to show you the event and just show you what it's like when people get together. They sit around, they talk, and they have a good time. You know, over on the left of the image, Armando Landrian from the Connecticut MUFON group, and he has a bunch of ham radio gear as well, and he's got his son who's also Armando, and they're talking about ham radio operation, and they're connecting to a repeater, and they're having a good old time. And then me, I'm standing here outside the observatory getting bitten up by mosquitoes, but over on in the middle of the view, we have other people that have arrived, and they're sitting around and they're talking. Connecticut's Mike Panicello is not here because he's actually running a fever, the poor guy. So he's unable to join us tonight. Too bad. Yes, everybody's saying get well, Mike. And hopefully he will. Yeah, that's right. So Mike will get better, and he'll probably join us for the next. Tonight, of course, like I said, it's a bit cloudy, and we're not yet seeing much of anything to see yet because it's still not quite dark enough, but it's also just a little bit cloudy. The telescope is up and running, and it is not running yet. I mean, to show people that anything, because the camera is pointing out in the yard at people walking around, and you can see we do have quite a crowd here actually. So I will soon enough. I will get the camera mounted on the telescope and go to town and allow a little bit of viewing if there's any kind of viewing capability. It seems to be getting worse, but either way, we should have some fun. So I shall continue to mingle with everybody, and I will talk to you all shortly. All right? I'm not going anywhere, and you're going to come with me as I go.
Guys coming in for a landing, and there's a lady that's going to the runway trying to pilot that way, and they may see that.
Like we can see it, but then like you
Yeah, you have to move it, and the Earth moving and stuff like that. Oh, Mark, your whole setup is all computerized, huh? It goes with the Earth.
Oh yeah, the telescope will follow the rotation of the Earth, yeah. And then the telescope itself is entirely controlled from my iPad, actually.
Okay.
I can control it from a computer, but the iPad is very portable. I can carry it around. Look like the guy in the Apple Store. Oh, you want this appointment? You know.
So you could view it at the same time, too?
Actually, the iPad can control the camera too, but I don't like switching back and forth between the telescope control program and the program.
Okay.
So I can actually do the camera control on my iPhone,
Yeah.
okay, and do all those exposures and all that stuff. And then I can do the telescope control with the iPad, you know, if I want like that. But I don't have to do it remotely like that. I can actually also do like the old-fashioned way. I can walk up and move it around.
Okay.
But once it's a like this, I have to let the computer do all the work.
All right.
Yeah. So I'm going to have to go get my iPad here, and then I'll be able to connect, or I can actually have someone do that, have someone get my iPad for me. But yeah.
How long did it take you to build it with the pieces there? I saw it in the
yeah.
You're building it. About a week, 2 weeks?
Yeah, overall, I would say. Yeah, I mean, I had to...
Get it fabricated?
I had to... Well, the shell was all in pieces. When this thing is all taken apart, the whole thing, believe it or not, the entire thing, dome and all, with everything all taken apart, will fit in a compact car.
Really? Wow.
Yep.
Amazing.
You put down the back seat, you know, I don't have a compact car, but I saw a photo of it in there.
Okay.
And
It still feels right inside the top.
right, they all nest inside. Yep, and they're really cool. Yeah.
Or polycarbonate.
Yeah, it's actually polystyrene.
Okay.
Yeah, or no, I think he said it was ABS. Sorry. But when I got them, a lot of the walls, they were cracked at the bottom because they got crunched by during the shipping. So he's going to send me 4 new out of 6. You know, 4 new walls. It's supposed to be, yeah, and it got broken. You know, but that's okay. And then I figured out when you move the dome, you'll hear a noise. See, like bump, bump, bump. Well, that's where the rollers are meeting the joint between the yeah. And there's a little, it goes up, and so the wheels bounce in there a little bit. Okay.
You gonna bring this to Arizona before winter time then?
Not this winter, no.
You're gonna have this over the winter.
Yeah. But in that little notch inside where these pieces meet, I've designed a little filler that can be stuck up in there, and I in my model shop, and so it'll make it smooth as glass to turn the dome.
So are the wheels attached to a piece of it, or are they just kind of floating in the...
No, the wheels are actually, there's wheels under here. There's a wheel that's like this on an angle, and then there's a vertical set. Okay, the angled ones keep the dome from blowing off.
And the vertical ones are to hold the...
The vertical ones actually support the weight, and the ones on an angle keep it aligned in the circle, and they also are able to make it so that the dome can't be lifted off too easily. But it locks in there too, so that if it gets like if it gets too breezy or whatever, I can actually you know, lock the dome down. Yeah.
Oh, what's that thing right? What's that? Is that a star?
Yeah, it's Vega.
Okay.
Yeah, that's Vega up there, and that's a plane right there.
Stars are coming out now, though.
Yeah, we're getting some stars.
It looks like a dot, right? And then
See, now that's the thing. See over there,
it looks like a dot.
we have a summer triangle right here. That's Deneb, okay, which is in Cygnus the Swan. It's the brightest star in Cygnus, okay. Then up there is Vega. That's the brightest star in the constellation Lyra. And then down there we have Altair, which is in the constellation Aquila, the Eagle. And those 3 stars form what we call the summer triangle.
Okay.
That summer triangle is something that sort of is a marker for us. We know where things are. If we look in Vega, up at,
There's a reference point then.
yeah, to find things. So we go to Vega, for instance, we can see a bunch of really cool little objects that are in Vega, and in the constellation Lyra up there. From Deneb, we can see a bunch of really cool objects in Cygnus, the Swan, including open clusters, nebulae, things like that. Because the summer Milky Way runs like this, right through there, all the way down.
I live in Britain, we got a lot of lights. I don't even know if I see the Milky Way.
Yeah, I know. Here you do. When it's clear, perfectly clear, you can actually see the Milky Way starting from over there, goes arching up through Cygnus, and goes down there. You see the Sagittarius star cloud. It's really beautiful. And then it kind of has some light down there that kind of infects it a little bit. But it's really pretty.
Mark, I have a question. I'm trying to acclimate myself.
Yeah.
Is that north?
Yeah, actually, the North Star is
Trees, right?
this way, right here.
That way.
Yeah, that's the. Actually, you know what? A good way to think about it is, see that tree right there?
Yeah.
That's, you know, right above there is about north. Okay. Yep.
I thought that picture, when they did that thing with the Hubble telescope where they pointed it at that one dark spot there and they kept it there for 30 days and they did that time lapse.
Yeah.
They saw all those galaxies. That's amazing.
Right. That's the Hubble Deep Field.
Yeah, that one shot just changed everything.
It did, didn't it?
It does. That one picture right there changed the whole, like, how
Yep.
small we are.
Yeah, that's exactly right.
And if there's that many of them galaxies, that one pixel, imagine, you know,
When I did, it was like
oh my God, they just put a
The sun's just one star.
Yeah.
one pixel of the galaxies up there. They pointed to one of the darkest spots in the sky there.
That's right.
and that was 0.
That's pretty good aiming though too. If you think about it, after that amount of time, 30 days, whatever it was. I might be wrong on the amount of days, but
well,
have the Hubble telescope in a satellite position to be able to point in that same spot.
Well, yeah, but keep in mind, there's nothing to move it.
Yeah.
Once it's in a position, it's not going anywhere. No, Warren, that's not true. You really are drunk. Cut it out.
Well, I'm not, but I'm willing to learn.
Oh, that's funny. That's funny.
You're all right, Marcus. Clear it up.
Well, it's trying. We're trying to get something out of this, because we can see some of the brighter stars, but it's really not, it's not a clear night like we'd want to have it, obviously, but... Yeah, Warren.
Having you front pointer and give everybody a tour of the sky.
Oh, sure. I can do that.
So hit the pointer here. Oops. See on the lawn.
Yeah, I got it right there. Oh, yeah, that's a nice argon. Oh, it's shining on my Pluto there.
Yeah, don't get any.
This is a slab of Pluto I printed on the 3D printer. Listen not to Warren. He knows not what he says. I just wanted to give you guys a little tour. Thanks to Warren, he's going to give me the I get this little light here, the laser. And let me go back and start with this here. If we look right there, I don't know if you can see that. Can you see that star I'm pointing at right there? That's called Deneb. And Deneb is the brightest star in Cygnus, and Cygnus is the Northern Cross. There's a star there we can't really see. There's a star there we can, and there's a star there. has found that most stars that are binaries, okay, can often have planets orbiting around both stars from farther out. Now, think about how complex that is when you have a habitable zone that is a not too hot, not too cold area around the star, and it's actually in a place where the star, these two stars are orbiting each other, and oh, thanks. And I'm gonna get this the right way, or just like spray Warren in the head or something. Okay, that's that way.
Too late, I already got my phone.
No, but the bottom line is, thank you, thanks, Dave. But so when you think about these binary stars orbiting, that's got to be a really complex environment for a planet to be in a habitable zone, doesn't it? Because as the stars are orbiting, when they're behind each other relative to you, then it's not going to be as warm on your planet. And as they come out from behind each other, then it's going to be the hottest it can be on your planet. And meanwhile, if your axis is tilted like the Earth's, okay, then you're going to have seasons as well, but your seasons are going to be either hugely extreme because of the two stars being side by side, say, in your sky. When they're end to end, you're not going to get the same radiation because one's going to block the other. You know, so very, very complicated. So can you have habitable zone? We don't know.
Did you ever have a planet traverse both stars in like a figure eight?
No, that's a complicated orbit. I've actually tried to generate that a number of times. I have a simulator that I've been using. Yeah, well, it's
certain part, exactly the same part of gravitational, have to be a certain amount.
Yeah, it's really, really difficult to achieve that. Yeah.
If there's ellipse with the plus side at the Lagrange points, that might work or something.
Maybe.
If one grabs it, that means it'd always be that one, because it's one stronger than the other.
Yeah, but you know what though? I mean, the slightest change, slightest perturbation from outside that system can cause that very, very delicate balance to be broken. That hasn't happened here. Although, we don't know, because we've only been here for at most 4 million years if you count Lucy, Australopithecus africanus out of Africa, right? Now but they didn't keep records. The records are early human records only went back about 50,000 to 80,000 years.
Yeah.
And then, you know, they didn't know anything about astronomy back then. They just, you know, yeah, people still think it's July 4th around here. Yeah.
What about else that I read recently about what we're supposed to be is, you know, the galaxy is rotating, so we're always moving into new parts of the universal space, and so we're supposed to be entering a more energetic part of the galactic cycle.
Well,
yeah.
Well, actually, see, we rotate around the galaxy center just like the Earth goes around the sun goes around the galaxy.
Doesn't the whole star system move up and down while it's traveling, or something like that?
Well, actually, we have a we move as we move through space. Our sun is moving through space at a few kilometers per second, and then we go around the galaxy once every 230 million years. We've done it 19.5 times since we were formed 4.5 billion years ago. So that's pretty cool. Only 19.5 times. But keep in mind that in that time, since we were born here on Earth, this whole planet was formed, this universe has been here for 2/3 of the time longer than that. So we were born in the last third of the universe's existence so far. Yeah. That's right. And think about it. Now, we see a sliding window of planetary formation. Planets just forming, like around Vega. Planets in the midst of their lives, like all the other, like the planets we found in Cygnus. Okay? And planets that have survived the death of their star. Okay? Like when we look in Lyra, okay, right down there in between the two end stars, there's a star down there called Chelyabinsk, and just above it is M57, the Ring Nebula, which is the remnant of a star that died and is gone. So we've seen stars that have formed planets around them, and the planets survive that, and their planets are in formation. Planets are in the midst of their existence, like us, right here. Okay, and so we see that that's a sliding window. It's been going on since near the beginning of the universe. It probably didn't start till about 1 billion years into the universe. You know, the formation of the universe. Okay, because that was about the time when we had enough heavier elements to make planetary stuff. Yeah. Okay, because remember, the universe was formed with hydrogen and helium, and then a little bit of lithium and some beryllium. Okay. Now, all the rest of the chemicals and the elements are in the periodic table. Where'd those come from? Those came from the hearts of stars. Okay, everything you're made of was made in a star once.
They call it star trail.
Well, that's right. Yeah. So, yeah, it's an easy leap too, right? Because if you're made of sodium, you've got a lot of chloride in you, chlorine. You've got the other elements. Yeah. Now, the other thing is up to iron, which is number 26 in the periodic table. Up to iron, that's the normal element that can be formed within a star. Up to iron. Okay, and those are only in the heavier stars. The sun can't make iron. Okay, but in these very, very heavy stars, when they die, okay, when they run out of hydrogen, it's a catastrophic event. The star is being held out by the radiation pushing outward and the gravity pulling in. That balance is very delicate. If the radiation slightly goes away, then the star begins to collapse because the gravity is starting to win out. If the star pushes out too far, then the star keeps on going and then ends up sloughing off its outer layers into space, and that's that. However, that delicate balance can last for billions of years, and that's what happens. That's why we see stars that last so long. Our sun is halfway through its cycle of its life, so we have another 5 billion years before we have to worry about leaving this planet, but we do have to leave here. And then when we look at the stars that are really heavy, when they explode, what happens is the hydrogen fusion, that is the making of hydrogen into helium in the heavier stars, and then the other thing called the carbon, nitrogen, oxygen cycle. It's called the CNO cycle. Those are the two ways that fusion happens in the universe. It's either made through this catalytic reaction where there's a dependency on carbon and nitrogen and oxygen to fuse the elements into heavier ones, or hydrogen is made into helium. Okay, that's it. There's no other way to make fusion. And so the heavier stars do CNO. The lighter stars like the sun do the proton-proton, the hydrogen and helium like we're talking about. Never mind the terms. Keep in mind there's only two ways to create fusion. That said, when the heavy stars finally lose all their capability to make carbon or nitrogen or oxygen, it just stops. Now gravity has got a free-for-all and the star just collapses, and it happens very fast. And it's rumored that the research shows that it might happen within a second or two. A gigantic star, millions of miles across, can collapse. And when it does, all that material goes right down into the core, and it just has no place to go. So what happens? It just goes boom, and it's a rebound bounce, and it explodes. And in that instant, that's when gold, platinum, silver, all the heavier elements are actually made. Is at that one point in time. And because we have veins of gold here, all right, and platinum and silver, okay, in fact, they throw silver away, okay, there's so much of it. That tells you that there has been an awful lot of stellar explosions going on, hasn't there, for this to be. And that's what's so cool about astronomy. You look at our periodic table, and to be an astronomer, you also have to be a chemist. You have to kind of understand the chemistry, because everything in the periodic table came from somewhere, you know. And where did it come from? It came from the stars, and that's it. And that was a supernova over there that we saw just now, that big flash, you know. Yeah.
Hey, Mark, so Earth's the major, right?
Yeah.
Is that Polaris there?
Well, I'll show you. Okay. That's the Big Dipper right there. That's the bowl of the Dipper right there. Okay. And there's the tail of the Big Dipper. Now, look at that center star right there, by the way. Okay. After the supernova. Okay. Do you see it as one star or two?
I can only see.
That star right there, is it one star or two to your eye?
Looks like a dot.
Yeah, probably two dots.
So there's two?
I see two dots.
Yeah. There's three. It's actually three, okay?
I can believe it.
Yeah, but you can only see that's Mizar, and you can only see Alcor, the obvious second binary component. Okay, and that's the tail of the Dipper.
That's where they found the comet in Deep Impact.
I don't know what you're talking about.
The movie Deep Impact?
I know that. If you follow that tail down, by the way, you come to this yellow star, and that's Arcturus. That's in the Shepherd, in the Shepherd, the constellation of Bootes, and you can see it looks like a kite right there. Yeah. See that shape?
Like an equilateral triangle with a side.
That's Bootes. Yep.
Center,
Yeah. And then the biggest, actually one of the brightest globular clusters in the sky is almost overhead in Hercules, in the Great Cluster in Hercules, and we can't really. It's right there actually. You can see it with your eye. It's so bright. The keystone of Hercules is right here. You see this trapezoidal shape, and then you see this bottom shape right here. Those go together, so it's like an hourglass. 1, 2, 3, 4, 5, 6, 7. That's Hercules. And then right there is the M13, Messier 13. When Charles Messier in the 1700s was putting together a catalog of objects, not to be confused with comets, because he was a comet hunter. He added that one, Messier 13, as an object to avoid. And it's right there.
Is that a galaxy though?
Okay.
No, Messier 13 is a globular cluster. It's a cluster of about 250 to 350,000 stars. And you know, if I can just, I could probably show you this thing actually. It's getting to the point where we may actually be able to, even in spite of the clouds, I can actually probably show you some of these things.
I have a quick question about
Sure.
For a planet, when we talk about the heavier planets, to have gravity, is iron an absolute necessity? Gravity on a planet without iron?
Yeah, mass generates gravity, you say, so whatever that mass is made up of, it doesn't matter. If it's just a nickel asteroid with nothing else, you'll have gravity anyway. So iron isn't necessary for gravity. It's just a little heavier. I mean, as is lead, okay? But you know, but you don't need any one specific element for gravity. They all combine together.
Okay.
Sure. Alright, what I'm going to do here is I'm going to go and get my iPad, which controls the telescope, and I will transfer my camera to the telescope, and I will try to show you anything I can, because I have to go kind of where the sky tells us to, and where the clarity goes. Here, Warren. Thanks. Oh wow, that looked like I thought I was having an epileptic seizure there for a second. I'll be right back. You probably can't hear anything now. Oh boy. Oh, it's not in here.
Hello?
Hey.
What's up?
Hey, can you do me a favor and get me my iPad that's sitting on the nightstand next to my bed?
Sure.
Yeah, sorry. I forgot I needed to control the telescope. Thanks, buddy.
Okay. You gotta get up.
I'm at the bottom of the stairs.
Okay.
Alright, bye.
1 second.
Sorry, folks. One moment. Thanks, buddy. Okay. I am back. Sorry about any static noise. And let's see here. We just hang up this here. Okay. That's not me. Okay, let's see here. Okay, I'm going to take the camera off of the tripod.
Yeah, help with that, let me know.
No, thank you. I'm all set. I just need to stay out of my own way, that's all. Well, thank you, Dave. Alright, so now... Okay, now we're back in the observatory, and it's a little bright in here because of the nature of things. Okay, now I'll put this down, and I'm going to get the telescope ready. This, alright, telescope goes there, or that thing goes there. And now this goes here. Okay. There we go. Alright, and now I'm putting the... Alright, I have now put the camera on the telescope. So, no more crowd views right now.
I don't think you're going to see anything that way.
Oh, I know. You're absolutely right. I'm not going to see anything with the telescope pointing where it is pointing. There's no doubt about that.
What's that spiritual tank at the bottom of your driveway?
Oh, that's actually not a tank. That's actually do you have a red light on that at all?
I have one.
No, I don't need it. I'm just asking if he does, because it's just aiming in my face.
Is there a red light?
Yeah, I'm showing him if you have a red light for that.
That'll forget that.
Okay. Alright, so.
Yeah, sorry.